Hey everyone, welcome to Application Development Virtual Group webinar. My name is Sarah Huang, the co-organizer of this virtual group. Joining me here is Debbie Huang, our co-organizer as well. Today, as you know already, Andy Warren will present SQL Server performance tuning for developers. Andy is a SQL Server consultant and trainer based in Orlando, Florida, focusing on administration, performance tuning, and SQL Server patterns and practices. He's been a SQL Server MVP since 2008. Andy served 2 terms on the past board of directors, was a founding principal on SQL Server Central and created both the SQL Saturday and Saturday Rally event models. We appreciate Andy taking Saturday night to present for us. Let me first go through a few housekeeping stuff, then I'll switch screen over to Andy. Because of the COVID-19 PASS Summit 2020, we'll have both in-person and virtual event. In case in-person event to be canceled, the registrants will have the option to go to the virtual event, and then you may get a cash or credit refund for the difference. And if you were to register, please use this code VGDISHX2H to save $150 of the registration. And PASS Summit 2020 pre-conference has been announced and already flying off the shelves. And if you want to learn more, please visit this link at the bottom. And PASS also released the complimentary content for the PASS Summit 2019 for free for those top ones, top content. These are the upcoming virtual group webinars. If you register for these virtual group, you should be able to receive an email notification from different virtual groups. And as always, if you are not a member of our virtual group, you're more than welcome to join us, which is the first one, Application Development Virtual Group. And PASS has a career center for job hunters as well as the employers. So you can find out more information by visit pass.org careers. And this is how you may connect with PASS through Facebook, Twitter, LinkedIn, Instagram, and PASS TV. And the membership is free for PASS. This is how you may ask questions during our Q&A by either raise your hand by clicking this little hand sign. Either me or Debbie will unmute you. Otherwise, you may enter your question into this little chat window. And if you were to change the Zoom, you can click this ribbon here. It says Zoom, and by changing this, you should be able to enlarge your screen or something. Go to webinar screen. Okay, this is all I have. Now I'm gonna make Andy the presenter. Okay, we can see your screen now. Thank you so much, Andy, for present for us today.
Great, thank you for inviting me. Good evening, everyone. I'm in Orlando. It's about 9 o'clock on Saturday night. The weather's pretty nice here, and so far everybody here is healthy, and I hope you are as well. So tonight we're going to talk about performance tuning for developers. On a daily basis, I work with 30 or 35 developers on a SaaS product. So, I spend a lot of time working with them, uh, trying to assist them to write good SQL, better SQL, try to solve performance problems that come up as we grow. Because a lot of times when we build something, we don't really know how it's going to be used or how much it's going to be used. So I think those are common problems. And as I talk to them and try to teach them how stuff works, I definitely see there's some common misconceptions and some places where they simply get overwhelmed with the complexity that is SQL Server. So tonight I've got a little bit of a mishmash of material that I want to show to you. Some of it's about kind of a philosophy of how you should work with a DBA and what you should expect that you should know and when you should expect someone else to jump in and help you. There's some patterns and practices that are good about 90% of the time. There's always exceptions. And there's a few things maybe I can just change how you think about how the product works, because there is real complexity in some of this, far more than you'd expect in some cases. So let's dive in. So in general, we're going to talk a little bit tonight about how to monitor the performance of a query, how relational design really maps to good performance. Those things are really tightly tied together in SQL Server. We're going to talk a little bit about indexing. I bet you've all heard about indexing, probably created an index. But what I want to do is kind of give you a mental model that I think might help you understand how they help you and how sometimes they hurt performance. In particular, I want to talk to you about why select star is bad. I love having this conversation with developers. We'll have some fun when we get there. A few common misconceptions, and we're going to talk a little bit about query hints. And depending on the time, we might jump over and do a couple of query demos. But really, I want to show you how to think about performance tuning as you do your work in an application. So I know you're going to hate hearing this, right? But the truth is it depends. A lot of what makes SQL Server really interesting is there's no one-size-fits-all solution. It's not like working with Redis, where the lookup time it's constant. It's a very sophisticated platform that we work with, and it very much depends on your workload and your goals and some trade-offs. And it doesn't always do things the way you would expect. It usually does them in a predictable way, but just not the way that you would expect. So here's an example that I like to ask when I'm teaching is to go, if you have a query that you run against 1 million rows and it takes 1 second, how long will the same query take against 2 million rows? So I just want to pause there. I want you to think about that for a second. If the query takes 1 second to query 1 million rows, how long does it take with twice as much data? Now, by far, the most common answer is 2 seconds, right? And the reason for that is most developers, and I'm generalizing here, I apologize if you didn't think of that as an answer, because they think of it as a big for loop, right? If I'm iterating through 1 million rows, looping, and it takes 1 second, it's going to take 2 seconds to do 2 million rows. So the challenge in SQL Server is it depends, because it depends on how we were doing the query. If we were doing what's known as a scan, which comes in a few different varieties, but you'll often hear us talk about a table scan, and that's really iterating through every row in a table, then absolutely, doubling the rows doubles your access time in a simplistic way. But if we're using an index that matches our query, in truth, it probably takes almost no more time to query 2 million rows versus 1 million rows. I often tell developers a query is not really interesting until you're running it against 100 million rows or so. SQL Server is astonishingly fast. So when you're only working with a few thousand, 10,000 rows, it's just not interesting, right, in terms of really trying to make that perform well. So I told you I wanted to talk about philosophy, right? Because I think what I want to do is shape your expectations about how you do the work and about how you work with the people in the team, because I think it's important to build that relationship, that contract. Um, so the first thing I believe is that every developer should have SQL Server installed locally. They should have Management Studio or the equivalent installed, and that way they can be sysadmin locally. You can run all the tools, you can experiment, you can do all that. I don't want to get in your way or make a lot of rules. If you need some help setting it up, absolutely, I'm there for you. And if you break it, I'm happy to come help you fix it. So beyond that, though, the next thing I look for is that, your job as a developer is to write the query, right? I need you to write the query and get the answer, and then we can look at that and figure out if there's a better way to do it, right? Because writing the query involves really understanding what the business thing is, what set of data do you need to return, and then trying to figure out how to get it, right? So, what I don't want to do is be in the place of where you're explaining to me all of this stuff, and I'm writing the query for you. To me, that's just adding noise to the process. That doesn't mean you might not ask for help to go, hey, I don't know how this works, or I can't get this right. But really, what I want you to work on as a developer is write the query, show me what you want to accomplish, and then I can look at the query plan, I can look at the indexes, I can decide based on everything I know about the system and about what you're telling me about the query, how hard I should try to make it run faster, because not all queries need to be tuned to the nth degree. So I'm not expecting you to tune the queries, right? And that might surprise you. I'm really expecting you to write a query that returns the right answer, and do it in a way that's not ugly, right? I mean, don't use a loop. Um, you know, do a little formatting, use some aliases, whatever the local code standards are, but write the query. And then I want you to talk to me, drop me a note, call me, Slack, whatever, and say, hey, this seems slow, or I'm worried it's going to be slow. Could you test it against a copy of production data? Or it's not slow, but I think we're going to call this 1,000,000 times an hour. So I want to see what you think about that, because maybe the individual performance is okay, but how is it going to hold up under concurrent load, right? Those are all places where I'm not expecting you to solve that, but I want to partner with you. But I'm not going to look at everything you write, right? I'm not the QA guy, I'm not the performance load guy. I'm really there as a consultant when you tell me you need help, or when a problem comes up after the fact. The same thing is true about table design. If you'll design what I call a reasonable table, as best you can figure out how to model it and add the primary keys, I'll help you review that design and then figure out which indexes we should add. I'm never going to fuss at you as a developer because you didn't add the right indexes. I mean, that's not your core skill any more than my core skill is, Java or C Sharp. And as you and I have these conversations, I really want to try to share with you why I prefer something one way or the other. And a lot of times what I'm trying to share, which is hard, is that it depends, or it's fuzzy, or I just have a preference based on experience that I may want to go one way or the other. But I want to share that knowledge with you so you can see, so you grow as we do this. So the starting place, I think, for understanding performance, right, as a developer, because if you're here tonight, I think it's because you know how to write queries, but maybe you don't have a DBA, or the DBA doesn't have quite the same philosophy I have, or maybe it intrigues you, or it feels like a weak spot in your game and you want to learn more. So the first thing you have to figure out is, how do you measure performance? How do you look at performance? And I want to talk to you about 3 different ways to do that before we get into some other details. So the first one is Profiler. Now, you may have heard of extended events, and if you prefer extended events, I'm absolutely fine with that. But for what most developers do, I find Profiler to be a very, very effective tool. And I'm going to bring that up and just do a little demo for you in a minute, but I want to talk to you a little bit first about the stuff we're going to look at. So every time I've talked to a developer about using Profiler, the biggest problem they've had is they're simply overwhelmed by the amount of information that comes back in Profiler. It's like the literal fire hose. So what we've got to do is reduce the size of that information stream and then be prepared to look at it asynchronously. We don't need to consume it while it's happening. We can capture it, store it to disk, and then look at it. We can even write queries against it. So I'm going to show you how to do that, how to build a template. And as we do the tuning, we'll come back to this a little later on. We'll try to look at some actual queries. Remember that our goal doing transactional work, and that's my focus, is transactional work. It's not data warehousing work, is that we're really focusing on reads and duration. In 99% of the time, if you reduce the reads, you'll reduce the duration. And remember, duration is the only thing that your users and your application cares about. Your application doesn't care how many reads it took. It just cares what was the duration of that query. So we're going to use Profiler as one of the ways that we can measure that. And remember, of course, this is like any kind of ad hoc testing. As long as you're testing against the same set of data, more or less, then you can change your query, you can do some stuff, and you're pretty much comparing apples to apples. But if you're adding a bunch of data or removing a bunch of data, that could throw off your comparison. So this is pretty easy to consume. So let's shift over to Profile. So I'm going to start a Management Studio, and we're just going to go up and launch Profiler. And we're just going to do a new trace here. All right, so I'm going to start off here and show you what the standard template looks like. So you see right here where it says standard default, that is the default template that Microsoft ships. So if we click over an event selection, you can see this is by default the events on the left, and then the columns going across the top that Microsoft has selected by default. What I would tell you to do is uncheck the security audit. You don't care. Uncheck the existing sessions and uncheck the starting event. One of the patterns you'll see in Profiler is we have this concept of starting events, excuse me, and completed events. And for most of what you're going to do, you're just going to care about the completed events. So we're going to leave just these two events checked, which is basically for inline SQL and stored procedures. We're going to check this text data box. And then if you've got a little bit of time, you can go over and you can turn off this client process ID. You're never going to use it. And then what we will do here is we'll click on Show All Columns. And we'll come across here and we'll add database name. We'll add host name. These are things that you're going to find useful. And then this one out here doesn't always return what you might expect because it counts every row that gets used. But a lot of times it can really help you understand how much work is being done in a really simple way. So right now what I've done is I've just customized this, and now I've launched Profiler and I can see what's going on. But I don't want you to have to do that every time. So here's how you fix that. So we're just going to stop the trace. We're going to go up here and save as a trace template, and then we'll just give it a name. And I'll just call this Andy default. And now, if I go back over to templates and I go to edit template, I can take this list, I can find my Andy default, and I can make it the default trace. So with that done, I'm going to close the original session I had. I'm going to launch Profiler, connect back, and you'll see now I've got this much simpler. It's going to greatly reduce the volume of the information that comes in. Now, when you're working on this locally, you're going to see still going to see some noise. For example, SQL agent runs. You may have some other stuff running. Remember, there's a whole set of filters in here that you can use to filter that stuff out. You can just come down here and add and say, I don't need anything that starts with SQL agent. And I apologize, I can't remember if there's a space in there or not. And just filter that stuff out. But that's the first part of just reducing the noise. So let's go back over here and just run like some kind of simple query just so you can see what this looks like when you run this. So there's the first query. And now I'm going to do where I can't type. So we're going to do for last name equals Sullivan. So if we go over here, you can see already, right, there's a little bit of noise in here. We might want to do some additional filtering. But what I'm going to do for right now is I'm just going to stop. So I stop the session, and then I'm just going to look here and see if I can find my query. And one easy way to do that is just to search and look for Sullivan. And there's my query right there. Right, so you can see what I did. And then if we look at this, these are the numbers I'm going to spend time looking at. Are the reads in this column. These are logical reads. It means we read from memory, and if SQL needed to go to disk, it went to disk transparently to us, and it took 9 milliseconds. This is a pretty good query. Not stellar, but pretty good query. 9 milliseconds is definitely acceptable for doing this. But really the key here is you see you've got all this noise, and it just takes a little practice to filter this out. Now, if you struggle with finding it or filtering it, one of the easy things to do is to come over here and save it as a table. So in this case, it's not a good practice, but I'm just going to write this into master so that it's easy to find. Typically, you would put it in like, some kind of user database. And then we'll just come over here and see there's our trace output table. And now we can just filter where text data looks like Sullivan. And then we can get all our rows there. So at this point, right, you can write queries, group bys, push it into Excel. It's your oyster right here. So there's a lot of interesting tricks that you can do with Profiler, but it all comes down to most people give up because they see all this noise in here and they can't sort through it, right? I'll tell you one very, very common thing that I think will help you is if you give every application a name and a connection string, it is wonderful to be able to filter on application name and go, I just want to see what's coming from that application, right? That could be a great way to filter it down. Another way to filter it down is by the SPID, which is the connection ID. So if we go over here and take a look at these queries, I'm running this on SPID 59. What we should be able to do is just filter on that guy. So we're going to click up top here on the properties, go over here to events, do the filters, go to the SPID, and say, I just want to watch SPID 59. So now if we go back over here and run this query a couple times, now look at it, there's a whole lot less noise. Now we can just focus on what's going on there. So let's flip back over to the slide deck now. So that was a really quick run through about using Profiler. If you haven't used it before, I really encourage you to try it. If you've been overwhelmed by it, go back and take another look, and this time go, oh wait, it is overwhelming by default because that template isn't the greatest. Let me make a template. Let me think about filtering and see if that makes it more useful. Now, the second part of 3 of assessing performance is to look at a query plan. So let's go over and look at a query plan, and then we'll come back and take a look at these notes. So there's a couple different ways to turn on query plans. I always use the Control-M shortcut, but you can see there's some buttons up here where you can look at an estimated plan or an actual plan. But I want to use an actual plan, which means we're going to run the query, and we're going to see exactly how SQL Server essentially wrote the code to go get the answer to that. So I turn that on, I'm going to run the query, and now you see I've got an extra tab here for the execution plan. And this one doesn't look too bad at all, right? It's just a few things, maybe we don't know what that means, right? Not too bad. But let's go over and look at this one. So I'm going to do Control-M here to turn on the execution plan. We're going to run this, and now you can see that you've got a whole lot more stuff to sort through, right? There's a ton of information here. If you want to really get into the details, you can even go look at the XML and go, this is everything that SQL sends back. excuse me, that's used to generate the query plan. And I imagine you're looking at this going, that's fascinating slash overwhelming slash I don't care that much. And that's absolutely fair. It's a lot going on, and a lot of it isn't going to matter for what you're doing. But the quick rules of this, when you read a query plan, is you're going to read from right to left. You're going to start over here at the far right. You're going to read over, down, across, and you're going to finally wind up over here at the final operator, which is what is going to return the results, whether it was a select or an update or whatever. So when you read a query plan, you're going to see a lot of stuff in here that's 0% or 1%. And you don't care about that stuff. What you're really looking for is the thing that takes a lot. So over here, we can see that we're doing this cluster index seek. We're looking at 290 rows to find Sullivan, and then it's bringing back all of these columns right there in the output list. So that seems like a lot, but at the same time, for SQL 290 rows just isn't very interesting. So if that is the most expensive part of the query, the odds are good we're not going to gain a lot anywhere over here, because you can look, see these are all zeros. And I'll just point out as we're looking at this, you'll see here's an example of a scan, right? Scans are one of those things that sound bad, and sometimes they are, but in this case, we're only iterating through 290 rows, so it's incredibly cheap. We don't necessarily need to fix that. But if you're looking at that as a developer, you're thinking, okay, I wrote this query, I'm going to go look at the query plan. Is that the easiest thing to consume? What am I looking for? How much time should I spend there? And I would agree with you. It's not the most effective tool for you most of the time, but if you don't have a DBA or you're trying to take your skills up to the next level, this is a good place to spend some time. So let's go back to the slides, right? So the trick to this is to go look at one query at a time, read it right to the left, and then I would say you're really looking for, to start with when you're learning, 3 things. The first is look for that highest percentage operator, and based on what you know, think about, is that bad or how could I change it, right? Because you may look at it and go, oh, I see why it's doing that, right? The second thing is if you're missing an index, SQL Server will tell you that in the query plan. You'll get a little note up at the top that says you're missing this index. Some of those warnings and suggestions are horrendous. Please don't think just because Microsoft says that you should add this index that you should. Sometimes the recommendations are bad, right? They work, they're technically valid, but they're not what you want to do. Sometimes they just don't make sense because there are other things that you want to do first. But you should always look at them and go, oh, that's interesting. And then finally, you always want to look for what's called a cluster index lookup, or if you go back a ways in SQL history, a bookmark lookup. And that's really cases where we're going to get stuff one record at a time, and then we're going to get another one. But we'll talk a little bit about that some more when we get to the index portion of the presentation. So far I've shown you 2 ways that you as a developer can look at performance. One is looking at Profiler, which is great, but it's a little complicated. But it's great because it shows you the duration for the query, and that's something you can think about and go, is that good or bad? Do I need to improve that? Query plans show you a lot of details about how it's working or maybe why it's not working as well as you want, but it takes a lot of experience to consume and figure out, even if you understand what it's telling you, how do you get it to do something different? So there's a third option that honestly I find the best for most developers, and that is Statistics.io. So we're going to swap back over here to this window, and all we're going to do is this. We're going to do set statistics. Wow. And we're just going to run this once, but you can run it every time if you want. So now when I run the query on the Messages tab, I'm going to get some extra information. So now you can see this is every table that I've addressed as part of that query, right? Because we don't really know, we haven't looked to see what's in this view, but essentially it's all of this stuff. And so now as we look and see what happened, we can see that really most of the work happened on the person table. That helps us kind of get a head start about going, why am I reading 897 pages from the person table? Maybe I could filter that better. Maybe I need to go take a look at that V employee view and see what the join looks like. Maybe I need to write a new view or just write my own query instead of using the view. So, there's a bunch of detail out here about read-ahead reads, logical reads, and physical reads. What's interesting is most of the time, if you have a physical read the first time, if you run it again, you won't have physical reads the second time because it's going to be cached up. Now, this shows you all the individual numbers, but sometimes you may want to look at the totals. So let's break out of here for just a second and see if I can find a browser right here. And so what I did is I used the statistics parser that just will total it all up. And now you can see that the total was 920 reads. Now this number may vary a little bit from what you'd see in Profiler. They calculate it just a little bit differently. But the trick is just use one or the other when you're kind of comparing, query variation A with variation B. Either use statistics.io for everything or use Profiler for everything. But you can look at this and go, yep, this is the guy right here. This is the one that's slowing me down, this person row, 97% of the reads. I find most developers find this to be approachable and useful, and they use it a lot. Sometimes they'll go to Profiler, and much less frequently they will take the time to look at a query plan because it just doesn't kind of fit into their work or their workflow. So I got to find my presentation. All right, so we're back. So that was a quick overview of the 3 ways for you to look at Performance Profiler, looking at query plans, and Statistics.io. I really hope you'll try Statistics.io. I think it'll help you, because you can just turn that on and use it all the time. It's lightweight, easy to consume, and you'll start to get a feel for what kind of work is being done. So now let's move on and talk a little bit about design philosophy and how relational databases really map to good performance. And there's no way to talk about this without getting under the hood a little bit, maybe not all the way down to the metal, but a little closer. So the thing about SQL Server is everything lives on 8K pages, and we do almost everything in 64K or increments of 64K. So the time it takes us to access a row on a page isn't interesting, right? When we look at reads in Profiler, that isn't the number of rows we read, that's the number of pages we read. Once we get a page, it literally, we don't measure the time it takes to find a row on a page. So the more rows we can fit on a page, right, the greater that density, the faster we can do things. And so when you go, okay, that sort of makes sense, right? I'm going to pick up 8K chunks. I want to get as few chunks as possible. One of the ways to do that is to use the best data type that you can, right? It means, if you can use a tiny int or a small int instead of an int, you should do that, right? When you use like a GUID as a key, that's 16 bytes versus 4 for an integer, right? If you use Unicode, the nvarchar, that's 2x the number of bytes in most cases compared to the ANSI versions of it. So you have to really go, do I really need this to be Unicode compatible? And if you go further than that, imagine that you're storing, for example, the state name, right? You could put in Florida, or you could put in the country of the United States or Canada, or in a relational design, a lot of times you would have a code or an integer that represents that. You might have FL for Florida that points to a table of states, right? That's kind of a relational design. But what's interesting about that is now we've taken Florida, that for every person in your table that had that state, from 7 bytes down to 2, right? We've made the row narrower, and that means we get more rows on a page, right? So Good relational design really forces us, encourages us, I guess I would say, to do narrow columns and narrow tables because that increases how much data we process for each IO we do. And even though we're living in the age of SSDs and NVMe, it still matters, even if you're processing in memory. It is always going to be faster to scan 500,000 pages than it is 1,000,000 pages, and that adds up over time. So relational design and performance really correlate in a really interesting way, and the more you get used to that and work for that, honestly, the better SQL Server will work for you. Now, honestly, at the bottom right, I've got the last note about, don't be absurd. And, there are always trade-offs in a design. You could take a contact table and go, well, you know what, I'm going to create an address table, and instead of storing, address 1, address 2, city, state, zip, I'll store that in an address table. There might be times when that's perfectly appropriate, but sometimes you just look at it and go, yeah, that feels like we're carrying normalization one step too far. We're not solving a business problem. We're trying to do an academic exercise, right? So we're always trying to go as normalized as we can, but we're looking for that tipping point where we go, this isn't adding value. It's making everything harder, right? Should we stop here, right? Is this really the right step for us to take? And that really comes with experience and an understanding of how your business works and how you think your business is going to evolve. So whenever you as a developer are building new tables, and I know it's not something you do every day, but I bet you do it on an occasional basis. What I'm looking for is a reasonable relation design as best you understand the problem and as best you know how to design it. But then I'm looking for every table should have a primary key. You should declare any foreign keys exist, right? It's so important to declare the foreign keys up front because it's so much harder to get them added later. And then any constraints. So if you know something can't be null, if you know something is restricted to a set of values or a wildcard or a formula, I want you to put all those things in up front, right? In large part, to be fair, because that's the time to do it. Is if you do it on day one, you never have to go back and figure out how it got broken, why your data is inconsistent. You just get it right from the start. On the performance side, though, SQL Server uses all of that metadata to try to help shape how it does a query, right? So a great example is, let's say you're writing a query and you've got like an order and order details table, and you're doing a left join from details up to orders. If there's a foreign key there, it will internally coerce that to an inner join because it says, I know the order has to exist because you have the foreign key in place. So it can do a smarter query. If you're doing a column, doing a where clause where you're going where this column is null, but the column is not null, it can shortcut a lot of work there and go, hey, I know something about this that I could use to influence how I execute this query. So just doing all those things up front are just part of building a solid foundation for your application because it's like 10x expensive to go back later and try to retrofit that and make sure that you can add the constraint without breaking something. All right, so now let's talk about indexes. So indexes are like, they're worth a day or maybe a week discussion, but I want to try to boil this down to a couple minutes. So here's the thing I think that will help you the most when you think about indexes. They are a copy of your data, right? Every column that you add to an index is a copy of that column out of the original table. It is essentially denormalizing data for performance reasons. Perfectly valid, right? But by doing it using SQL Server, by using the index functionality, we guarantee that the index will always be correct. And that's really important because there are times when we're going to satisfy a query solely by looking at the index, right? So if the index isn't exactly in sync with the table, we're not going to get the right answer, right? So we rely on SQL Server to denormalize data using indexes for performance reasons. So as a mental model, right, we often talk about indexes or B trees or these advanced structures. You can certainly deep dive into those, but it's probably easier to picture an index as a table that's maintained by triggers on the source table. So if you've got a table with 1 billion rows and 30 columns, and you create an index on that table that has 3 columns, you can go, wow, that's going to be a 1 billion row table with 3 columns. That's interesting because it's narrow, one of the things that Andy talked about in the presentation, but it's still going to be a lot of data sitting on disk. It is not uncommon to see systems where the space used on disk for the indexes exceeds the space used by the table itself. And I'm not saying that's good or bad, but just we kind of think of indexes as these magical things we add and it's faster, but we actually have to maintain those. And so every time we change a row in a table, right, an insert, update, or delete, SQL has to go look at every index on that table that is tied to one of those columns and update it also, all within the scope of that transaction. That's great, that's the way it should work, but it also costs something, right? So as you build indexes, and I'm not trying to discourage you from doing so, but to help you understand that there's a reason why they work, and that's important, and there's a cost to making them work, and that's important also. But in general, I would look to have 3 to 5 indexes per table. Certainly, I'm looking for an index on the primary key. Sometimes that'll be the only index, or maybe there'll be one other index. But 3 to 5 is normal. There are cases where you'll have more, right? But 3 to 5 is a good number to look for. Now, when you build an index, right, in most cases, right, because there's always exceptions, you're going to put the most unique value in the leftmost column, right? That's really important because when SQL Server looks to see whether it can use the index, it's doing what we call a leftmost seek. It's looking at the left column and then 1 in from the left and then 2 in from the left. And if you're not looking for that leftmost column, or the leftmost column isn't very selective, right? And by selective, say for example that you have something like you have companies that are clients, and every company has a company ID, and then there's an order ID. Well, if you think about how you organize that index, you could put company ID first, or you could put the order ID first, right? There are times when you might want either one, but in a lot of cases, you're going to be looking at an order ID, and you want that to be the leftmost column. So whenever you use an index, don't just assume that it's magically solving your problem or that it didn't solve your problem. You have to go look at the query plan to go, is it consuming that index I created? Because there are times when, for whatever reason, it won't, right? And it's important to figure that out because maybe you declared it wrong, you got the column order wrong, or there's something else going on in the query where it says, I still don't want to use that index, right? So that's one of the times when I think query plans are really important to a developer, is when you're adding that index to make sure that it's being used. So next, I want to talk about a covering index, a covered query, and then we'll see if we can go do a quick example. So the idea behind a covering index is that instead of having to go to an index, find first name equals Andy, and then go back to the table to get some other values, I can satisfy the query from that virtual imaginary table that is an index, right? And that's where we get into select star, and I'll show you an example of that also. But a covered index is really, really powerful, but every time you add a column, because you added a column to the query, that index gets wider. It takes more pages on disk. It takes more I/O to scan the entire index when you need to do that. And back early in the presentation, I talked a little bit about the idea of looping through everything, right? That we do a table scan. Well, it's also possible that we can do an index scan. In most cases, scanning an index is going to be faster than scanning a table. And in most cases, scanning an index is going to be slower than doing a seek, right? You could really think of a scan as a for loop, and a seek is like a binary search type operation that's crazy fast. But this is where the it depends things comes back. There are times when SQL will look at it and go, I'm going to do so many seeks, so many lookups, it would be faster to just do a scan. Really, really interesting. So let's go over and see. I don't think I have a great demo ready, but I think we're going to try to put one together really fast by looking at the person.person table. All right, so right here, we've got the person.person table, and let's take a look at what we've got here for indexes. This doesn't look terribly exciting, so let's run select here. And we're going to stick with our last name equals Sullivan. And we'll see we got back, a handful of rows. And I'm going to hit Control M to turn on the execution plan and see what's going on. So now here's a great example where it says, hey, you're missing an index on last name. So before we do that, I'm going to turn Statistics IO on and run this again. And let's just look at what this is costing us. So right now we're using 338.21 reads, right? It's not terrible, but it's a little bit heavy. But when we look at our execution plan, we see that we're doing a scan, right? We're looping through all the rows in there. And SQL says it could do it faster if we create the index. So what we can do is right here is we can right click, select missing index details. We can grab this query, this index, bring this down here, and I'm just going to name this Andy Demo 1 just so we can clearly see it. And we're going to create this. And we'll just comment this guy out so we can remember it. So now let's run this again. So same number of rows, that's what we expect. If we look at our stats, look at that. We went from 3,800 reads down to 38, right? That's nice. That is nice. And if we look at the execution plan, now we can see that we went from a scan to where we're doing a seek, right? We're finding those 12 rows, and we're doing this key lookup, right? The key lookup is where we have to go back to the table to satisfy the rest of the query. So let me show you what I mean by that. So if we change this query and say, I just want to bring back last name, we want to find all the rows with last name, 2 reads, crazy fast, and now it's just an index seek. Okay, so imagine this is your application and you're looking at this and somebody goes, it would be really nice if we brought back, the client's first name as part of this query so that we could use their first name, maybe when they log in, something like that. And you go, oh, that's an easy change. I'll just add that to the query, right? Add that to the query, no problem, right? We look at it, we've gone from 2 reads up to 38, but look at what happened with the plan, right? Now we go to the index, we find Sullivan really quickly. There's only 12 rows. And then for each of those 12 rows, we're going to go back to the main table to get the first name, right? Now, in this case, it's not terribly expensive, but it is, 17 times, 18 times more expensive than it was before we added first name. So we could fix that, though, by making a covering index. So what we're going to do is go over to that index that we created just a moment ago, and we're going to add first name. And we're going to add it right now as the second column. We'll come back and look at that in a minute. Okay, so now there's 2 columns in there. And we're going to let that rebuild. And we're going to run the query. And now we're back down to 2 reads, and we're down to just the index seek, right? So this is an example of a covering query. Now think about what happens as a developer, right? When you go, I don't want to specify column names. Why do you care how many columns I return? It's cheap. And you write the query like this, right? You can select star. Oh, totally broke it. So now we're back to the 38 reads and we're back to the lookup. So this is the problem with select star. It's not about how many bytes you're returning back or how many columns you're returning back. It's about that essentially it forces me to either always do a key lookup or to just do a table scan, depending on how many rows are being returned. That's why select star is bad. It's because for me to cover that index, I would have to, or to cover that query, I would have to add every single column to the index, which means that I have made a copy of the table. That's a lot of work. So let me show you another variation of this real quick. So let's go back to our index, and let's just say that when you added the first name, you added it as the first column, right? Didn't know how SQL works, weren't paying attention. And we're going to go just change this back to first name and last name, right? So we know that both of those columns are in the index. That's good. But now we're at 99 reads. It's gone up even more. And now it's telling us, hey, you're missing an index, right? We're doing an index scan instead of an index seek. And if we look and see what it's recommending, it says, oh, hey, you need an index on last name. And that's because we can't seek against first name in order to find the last name. The column order is wrong for this particular query. All right. So let me show you one last example here to get you thinking about how this works. So a lot of times you're going to use wildcards. And I would say if there's a trick that developers love, it's when you're doing one of those search screens, where they can search for this or search for that, is you like to bracket things with wildcards. So maybe we do something like we look for Sullivan like this, right? And we hide that from the user. They type in Sullivan, we put the wildcard on the front and the back, because that way if they didn't type in all of it, we help them find the results. We think we're being helpful. Let's take a look at what happens to the query plan. It forces it to a scan. Essentially, as soon as you use a leading wildcard, you're no longer going to get a seek. The trailing wildcards are fine. If we take off the leading wildcard and run this guy again, you'll see that we should get, I didn't change the index back. That was a really bad demo. I'm sorry. We'll change this back real quick. So let me back up and show you that, because I know that was a little confusing. So here's the query with the index the way it should be, with a leading and a trailing wildcard. And you can see we get an index scan. If we remove the leading wildcard, we should get a seek, right? So one of the things I would tell you as an application developer is never prepend that leading wildcard. Maybe get the option for the user to type it in or to click a box saying contains or something like that. But if you do that on every one of these you do, you are throwing out my ability to get you a seek instead of a scan. That's a really big deal. All right, so let's go back to the presentation. So that's a real quick overview of how indexes work. In general, what you were thinking going into this is that adding an index makes things go faster. That's absolutely right. But the column order matters, how many of them you make matters, how many columns you're adding matters. And the funny thing is adding one column to a query can make your index useless. You're still paying to maintain it, and you're never using it. That's the fun and mystery sometimes of SQL Server. All right, so I think we covered most of this about select star, but it's a great example because for developers, it doesn't fit their mental model. They're like, why does it matter, right? But I've just shown you that as soon as we go to the star, instead of going to using a handful of columns, it cuts down my options, as in SQL and the query optimizer, and even as a GBA to help you make that query run faster. All right, so now I want to go through a kind of a handful of patterns and anti-patterns real quick. The first one are table variables, right? I find developers like table variables. They feel cleaner than using a temp table. The problem has been historically is that statistics on table variables have been that it's always estimating that it returns one row. And that can lead to some really bad query plans when you're pulling that back into the rest of your query. So in general, right, there's a lot of times when it doesn't matter, but in general, you'll get better performance using a temp table because you can add other indexes on there and you get better statistics. I'm not suggesting you go back and get rid of all your table variables, but I would suggest that if you know there's going to be more than 50 or 100 rows in the table variable, you should probably think about changing to a temp table. One of the little pieces of magic around using a temp table is you want to declare all of those up top. Don't interleave those with your queries. And then think about how you're going to use them, about whether it's worth indexing them or not. If you're only going to look at that in that temp table one time, it may not be worth adding an index unless you need a constraint to guarantee that you don't have the wrong answer. But if you're going to look it up a bunch of times, it may be well worth adding a primary key or adding an inline index or even creating the table and adding some other indexes, all to speed up the operations that come after that. So two reminders in here that aren't necessarily related to performance. One is just a reminder that table variables aren't part of your transaction. If you do a rollback, the contents of the table variable don't get rolled back. And the other is if you're doing a temporary table inline and you're adding a primary key, you don't have to give it a name. And in fact, you don't want to give it a name because that name is unique and only the first person to create the table would succeed. Everybody else would get an error message. So next on the anti-pattern list are functions, right? Functions, I think, are one of those things that, they appeal to a developer, right? They encapsulate code. You're like, oh, this is great. I'll just have a get customer last name function, all those things like that. But they don't perform great. Now, there's been a lot of changes under the hood in SQL Server to inline a lot of those functions. I still haven't worked with them enough to tell you whether or not that's a magic fix. I'm going to guess maybe not, but we'll see. But in general, you're going to get better performance by writing queries, doing set-based operations, maybe encapsulating a little bit in views, but really not using functions except in really specialized situations. You still want to make it your go-to tool for working with SQL Server. It doesn't work nearly as well as what you would expect it would. So here's another one I think surprises developers, right? So for developers, views and nesting views seem like objects in inheritance, right? So you can kind of picture we have an employees table. We create a B employees view that only shows active employees. And then maybe we create a manager's view that is a select from active employees where a title like manager. And, we keep nesting all those. And what we kind of expect is for SQL to magically compress those and go, well, that's really just one query with some stuff. It doesn't always do that. Sometimes it just inlines the view and you just wind up with this monster query that does a lot of extra work when you could get there much faster if you just wrote the exact query that you need. I can't give you a perfect rule about when that's going to work and when that's going to not. Just my rule of thumb is that a single view is almost always fine. A view on top of a view is almost always fine. If you're starting to get two or more deep, though, in a lot of cases, you're going to see places where you could have gotten a better query plan, but the optimizer just times out because there's too many possibilities for it to resolve. I know that's really kind of gray, and that's the nature of working with SQL Server. All right, so let's just talk a little bit about expectations again. One of the things I expect working with developers is that you're going to write the query, you're going to follow whatever code standards there are. And I'm sure there's some smiles and smirks out there because you don't have code standards. Yeah, I get that, right? But, if you've been to a few different jobs, you know that once you get there and you look in the database, you will see that they have some patterns that they use. They start all their procs with get or select or set, or, there's some pattern. They use underscores or they don't. You're just trying to stick to whatever pattern they're using for object names and maybe even how they alias queries. Every table has a primary key. I expect, right, developers to spend a minute on data types, right, trying to figure that out. And then we're going to talk here. I've got another slide where we're going to talk some more about the parameters and the links. I decided to break that out into a different slide. But one really interesting thing I would tell you to think about that that you may not think relates to performance, but really does, is what's your data retention plan? Every time you create a table, it would be so great if you and the stakeholders would get together and go, how long are we going to retain this data, right? If we add a customer in 2010 and we look back in 2017 and they haven't placed an order in 5 years, do we still need to retain that? Can we delete them if they've been inactive for 5 years? Can we move them to, kind of cold storage? Or do we really want to retain that forever where I'm always having to search even though nothing changes? And it doesn't matter. But it hardly ever gets discussed. All right, so back on the performance side, I want to talk a little bit about plan caching and how that works, because it's another piece of the mental model that you have to learn to work with SQL Server performance. So essentially, the first time you run a query or a stored procedure, what SQL does is it looks in cache and says, do I have that plan in cache? Nope, let's add it, because it's expensive to calculate and I don't want to do it again. And we're going to use that same plan over and over. Now, stored procs, it's easy because it's this nice, clean contract that SQL Server understands. Now, for inline SQL, it can work equally well, but it all depends on how you write it, right? If you parameterized it well, then everything works out good. If you don't use parameters and you're literally gluing together a string, you can wind up in a case where every query is a new plan, and you wind up with thousands or tens of thousands of plans in cache, right? So if you can imagine something like you're doing where customer ID equals and concatenate customer ID, when customer 1 calls in, you got customer ID equals 1, that's a plan. When customer ID 2 calls in, that's a new plan. Customer ID 3, that's a new plan. They are all the same plan, but for SQL Server, it says they are not the same plan because we hash the query and they are different. If you want the hashes to match, you have to parameterize the query, right? That's really the trick. I see it over and over where, not understanding how that works just leads to plan explosion, where you just did all this work to just keep recalculating something for no gain at all, right? And it can be literally just adding a space or changing the case of a word. Even though our database isn't case sensitive, it will give us another plan in cache that we're just spending time on to no benefit. So this one I think is my favorite slide, and the one I think surprises developers maybe the most. And that is, I'm guessing most of you are working with ADO.NET, right? And you're used to, the command objects, and you've got the command text or, the command type store proc, right? I see two things that go wrong all the time. Where the query still works, it seems like everything is great, but it's, as a SQL Server guy, it's not great. The first is they don't set the data type of the parameter, right? And so I'll see places where they're sending in ints as strings, right? And that often, not as often as used to, but still can lead to conversion overhead where I have to convert it to an int. And that can cause me not to use an index. It can also cause it to look like a different plan because the links vary, where with an integer it's always 4, but if I use a string, I'm going to have 999, that's 3 bytes, 9999, that's 4 bytes. Each one of those is a different plan. The even more subtle mistake that I see, though, is they will type something as varchar or in varchar, which is great. They're saying, yep, it's a string variable. I'm stating that in line when I'm defining my parameter. But then they don't set the length of the parameter, right? What they do is they just say, parameter, customer last name equals 1, and then they execute the query. Well, the way ADO.NET works is under the hood, if you don't explicitly set the length, it will set the length to the length of the value that you assigned to that parameter. And so what that means is if you've got a parameter called last name, you're going to wind up with one that has a length of 3, length 4, 5, 6, 7, all the way out to maybe somebody with a last name that's 20 characters long. If you've got 3 or 5 string parameters in a stored proc, you can wind up with 30 or 40 or 50 variations in cache for all those different things, when really it should just be one plan, right? So you want to get in the habit of setting that parameter length to whatever the max is for that column, right? Which means absolutely you have to go look in the database and go, oh, yep, last name is a max of 50, set the length to 50, right? It's one thing you have to do, but it makes a lot of difference in terms of how much time we spend compiling plans and churning plans in and out of cache, which is all this hidden overhead that you don't think about or honestly expect, right? It's a little unintuitive. All right, and we're almost done. So let's talk real quickly about recompile, right? So I talked about just briefly that process SQL goes through, right? You submit a query, it does some validation to say, is it a good query? It goes through a bunch of heuristics, and then finally comes up with a plan as good as it could find within the time box that it was allowed, right? It doesn't guarantee that it found the best plan. It says it found the best plan it could in the time we had to work with. And then we're going to put that plan in cache because we don't want to pay for it again. So compilation is expensive, right? When I say expensive, it could be a millisecond, 5 milliseconds, 50 milliseconds, but it adds up on a high volume system for sure. So the first time we run the query, we're going to cache that plan, and that plan is going to be based on the parameters that we submitted, right? And if we're using an integer, something like customer ID, where the data is perfectly distributed, then that's great, we don't care. But if we're doing a query that does something like last name, imagine the difference you're going to get in the statistics if you go last name equals Smith or last name equals Quigley, right? Odds are there's going to be a tremendous difference in the amount of data you have for those two last names. So if the first query that gets run has the last name of Quigley, it's going to be fast. It's going to be great. But odds are that query is going to perform really badly with Smith, because instead of returning 3 rows, it might return 3,000 or 30,000. Right? It's all based on essentially luck of whatever parameters were passed in the first time we run that. You'll hear it called parameter sniffing, which I think is really not the most useful term. It's really going, that's all the data I have to work with. I'm going to make a plan based on that, and I'm going to cache it. So you get what we often call is a bad plan, which again is not the most useful phrase because it was a perfectly good plan for that scenario. It just doesn't work for all of our scenarios. So when that happens, we have 5 options, right? Now the big hammer is to say with recompile, right? If you think about a stored procedure, create proc, get customer by last name with recompile, what that says is every time I run this, come up with a plan based on whatever the parameters are for this execution, execute the plan, and then throw it away. So every time I run it, I'm trying to get the best plan I can based on the parameters and the current stats and everything else. And I'm going to trade off the overhead of compiling it every time in order for it to not break or not be super crazy slow in some cases. Now, the thing about with recompile is it means every statement in that stored procedure is going to get recompiled. We can sometimes be more surgical, though, by saying we're going to use option recompile, which goes at the statement level instead of at the stored procedure level. But it essentially does the same thing. It says, I'm executing this statement, take the parameters I'm giving you, come up with a plan, execute the query, throw the plan away, don't put it in cache. A different variation is to use option unknown, or at the stored proc, you can do something called optimize for, which is really a way of saying, I want to generalize the query. I want to, no matter what you passed in for the first execution, I want to optimize for Smith, or I want to optimize for kind of a middle of the road amount of data based on the current stats. So you can see those are all kind of coarse settings. When we get down to even more surgical, we can do what's called a plan guide, which goes back to maybe 2008, which is a way to say, if I see a query that matches this pattern, I want to use this plan, or perhaps I want to add or remove a hint from this query. And it's a way to override kind of the default behavior of the optimizer to go, no, no, don't do that work. I've got you. I want you to do this. Plan guides are really fussy to work with. They are also case and space sensitive. They're just a bear to work with. As far as setting them up, once they work, they're fine until somebody changes one byte in that query, and then it's not going to match the plan guide. And then the newest option we have, which is so much easier to work with, starting in 2016, is the query store. So what the query store allows me as a DPA to go in and look and go, okay, I see that we're using this plan, and then we changed to use this plan, but the older one was better. I can simply click on that plan, click force plan, and then going forward, SQL will try, not guarantee, but try to use that plan to execute that query. Because in most cases, I don't need 100 variations of a plan. What ends up happening is there's like a plan that works pretty good for everybody, and there's a plan that works great for only a handful of people. I need the one that works pretty good for everybody. And usually I can find that in Query Store, click the button, and it is so much easier than trying to do it with a plan guide. But you still have the same problem with plan guides, is that if somebody changes the query, it's now essentially a different query, and that forced plan isn't going to line up anymore. So that wraps up what I have for you tonight. I mean, that's a really quick overview of how I hope you'll start thinking about SQL Server and performance and the stuff you write that. It takes a lot of time to learn to program. It takes a lot of time to learn to use a database. And I love that you're here trying to learn about, more about how to make it faster, but I want you to keep in mind that this isn't trivial. It's not like working with simpler databases. It's not what, even something like Redis, right, where the rules are just simply smaller, there's a smaller vocabulary. This takes time to master. My goal is to help you focus on the pieces that really matter most to you, right, that are going to give you the biggest bang for the buck, but always take you back to the basics, which is to say that if you'll do good table design, you'll write a query that I can understand, right, where you can tell me this is giving me the right answer, this is what I need to do. If it's not fast enough, you and I can work together to try to figure out, can we make it faster with an index or any of the 50 other ways that we have to try to influence performance, now that we know exactly what you need to accomplish, right? That's the way we want to go at it. And so finally, before we get to questions, please, if you've got follow-up stuff or you just like to connect, I put my LinkedIn information. I'd love to hear from you. So Sarah, Debbie, I'm going to ship it back to you. Do you have any questions we can take tonight?
Yeah, we have several questions. First one is, would you be able to talk about how multiple joins in the same query can or may reduce performance?
Sure. So, obviously joins add a little bit of overhead, but they're what a relational database does. Probably the biggest factor when you look at joins is whether you're joining on indexed columns and what your where clause is, right? Not having a where clause, if you're joining a million rows to a million rows, that's a lot of work, right? There's no way around that. But if you've got a good where clause on an indexed column, it could add up to almost nothing. Really the same is true of foreign keys, right? You want to index that foreign key column in most cases because it's really a join, right, that's happening. I work with queries all of the time that have, 5, 6, 8, 10, 12 joins. Really, it's not a reason for concern. That's the nature of a relational database is we're going to join the stuff. We have to take a look at what it's costing us, acknowledge that it does add a little bit of overhead, but we're more than happy to take that trade-off compared to having one big flat denormalized table that would just be a bear to maintain.
Cool. So I'm just curious if someone only has read-only access to the database, would they be able to use the profiler?
Probably not. So profiler requires alter trace permissions on the server. So it is possible that they could give you alter trace, but then make the database read only. I mean, that's a valid combination that they want to do that. Whether they want to is a different thing, right? But Profiler runs at the server level, and you have to have the server level permission that's alter trace. So I would talk to your DBA about that. That if you want to use Profiler, I would just also say though, that's why I say it's so important to have SQL Server installed on your laptop, because then you don't have any of those restrictions, right? You can run Profiler or extended events. You can change indexes. You can really experiment there without having to worry about somebody else giving you permission.
Sure. So another question is, when should we use the temp table, table variables, and regular tables?
Okay, so I would say use a regular table anytime you know you want to persist that data, right? Table variables and temp tables are really where either for ease of understanding, it makes sense to, like, instead of write one big massive query, to go, I'm going to pull together this list of customers that we think we're going to lose. I'm going to get those into a table, a temp table or a table variable, and then I'm going to run another set of queries against that to really do some more analysis. Sometimes it's useful to take a query and break it up into chunks like that. I think that's a pretty common pattern. One of my biggest times to use a temp table is when I'm not getting great results because of stats, and I can pull it into a temp table, and then everything after that uses a much smaller set of better stats, or because I know that I'm going to join to that set multiple times, right? So a lot of people will write a CTE and go, a CTE that's called like active customers, and then they might join to that 2 or 3 times in a complicated query. Well, you're reevaluating that query each time. If you know you're going to use it multiple times, a lot of times it makes sense to go, I'm just going to take that query that's in the CTE, put it into a temp table called active customers, and now when I join to it, I'm not reevaluating those query results. There are times when on the table variable side, I'd say the most interesting scenario is because it's not part of a transaction, where you want to use that to your advantage. Say for example, you're doing kind of a complicated store procedure, and there are some things happening within the store procedure where you might roll back, but you want to retain some information about what was happening inside of that. You can use a table variable as like a log mechanism to retain that stuff outside of the transaction. At the end, temp table versus table variable is a lot about style, but sometimes it really is about performance. And I just can't really give you a better answer than that.
So following the question you just answered, the same person was asking, oh, never mind. Let me see. Okay, sorry. Okay, so earlier when you were talking about join, multiple joins, what if there's when you need to join 2 tables and you just so happen you have to change, say like when you join 2 tables based on some kind of date and time column, but instead of using the date and time, you just need to match these two tables with date, and then in that case you have to convert it, from date time to date, and then you link those 2 columns.
Right,
In that case, the index won't work anymore, right?
right. So there's a couple options there. One really complicated is you could do an indexed view where you could kind of hide that work. But a lot of times a better answer is, instead of just trying to join on the date, is to filter on the date ranges and bring it back and then filter it down, right? So you join across and you go, I want everything between, May 1st and May 3rd, bring those back and then filter it down after. But back to your original point, right? Absolutely. If you're trying to join on a convert, it's going to cause a scan, right? That's just how it works. And you have to really think about that. Um, Sorry, it's late. So there's one other option that you can use, and that would be to add a computed column. So you could add a computed column where you coerce it to a date, and then you can index the computed column, and that would give you a much faster join. You're moving the work. You still have to do that work somewhere, but in terms of read query performance, that would be much better.
So when you were saying use a computer column, does that mean you have to add this column to the physical table itself?
It is.
Like a boost table? Okay.
Right. Right. It gets added as an expression, right? So
Okay.
when you add it as an expression, you get two options. One is you can add it as persisted at the table level,
Mm-hmm.
if you care, or you can not persist it. They're not exclusive. You can do both. But when you create an index on that column, it is then persisted inside the index and maintained. So if any part of that expression is updated at the table level, any one of the columns that's part of it, then all of the related indexes will get updated so that it's always current. It's a really interesting trick for things like, say, when you're searching for like the last four characters of a social security number, where a leading wildcard would not give you an effective query. You can just put in that, that SSN fast column is equal to the right four of the social security, and then index that, and you get a really fast lookup.
Okay. Sounds good. Thank you. So another question is that does the order of the selected columns, say like when you using select statement, the order of the columns in your select statement matters in terms of performance?
It does not.
Okay, cool. Uh, okay, as in terms of CTE, if memory is large enough and the CTE is small set of data, I'm not sure what this question means. Okay, we'll just skip that one. How to know which step in query is slowest part?
How to know which part of a query is the slowest?
Yeah.
So there's probably there's three ways that I could think of off the top of my head. Maybe the first one is go back to Profiler, and when I showed you, I did the batch events. There's also a statement event. So you can turn on the statement completed, the batch statement, and the RPC statement completed events, and then it will show you for every single statement the reads and the duration per statement, right? So if you've got multiple queries, you can look at it that way. Now, if it's just a single query and you wanted to know which part of that is the most expensive, then you can either look at the execution plan and see, which one has the highest percentage, or you could turn on statistics IO, and that will show you which table had the most reads, which typically equates to being the most work, the slowest, right? To give you an idea of where the work is happening.
Yeah. So this question says temp table will be written to database physically, correct? If yes, does it matter to perform?
I'm sorry, what was the first part of the question?
The temp table. So he's wondering if the temp table will be returned to the database physically.
So it does get written out into TempDB. There's a bunch of optimizations around like table caching and a lot of things that go on there. But absolutely, you are writing that out to disk in most cases. The same for a table variable. It's not purely in memory. It's backed by SQL Server. But when you close that connection, the temp table goes away, right? You don't have to worry about cleaning it up. It just automatically goes away. Um, you just don't have to worry about it. Essentially, when it goes out of scope, it's gone. It gets cleaned up.
So you say like you use a bunch of temp tables in your store procedure. You don't need to drop them.
You don't.
Oh, okay, cool. Uh, okay. Another question is, what you mentioned about nested view, but what about nested store procedures? Would the nested store procedure will impact
Right.
performance?
Right. No, that's a great question. Typically, they work fine. At some point, I would say it is far less about performance than it will be about readability. I mean,
Okay.
if you nested inside nest and inside that, but in a lot of cases, you may actually get better performance instead of having like 500 lines of code in a single stored procedure. If you call a master stored procedure and it calls 5 stored procedures inside, they will all get their own plan, right? And
Hmm.
you can look at that as kind of a separate unit of work, and it makes it easier to consume. And in a lot of cases, you'll just get better plans for each of them, right? Just because of the way it compiles.
Okay. So, um, I'm not sure if you're familiar with the SSRS reports. So if someone uses um, a lot of stored procedure in the SSRS report, would you recommend they include something like a recompile, or what what's the better
Sure. So, reporting in a lot of ways is just like, regular transaction work. You have to understand um, the usage patterns and you have to understand the data, right? There's a lot of reports where doing recompile would just add overhead and no value.
Mhm.
There are other reports where you'll see a tremendous amount of variability, and adding recompile totally makes sense, or something in between. It's, I would tell you, it's not much different than any other query, um, because there's just a lot of factors that go into that. Like how often does it run? If it runs, once a day, twice a day, I don't care. Put recompile on there because it just doesn't matter. If it runs 1,000 times a minute, I really don't want to put recompile on there if I could help it, because it might double the overhead of that query.
Right. Say like, normally SSR's report probably will be viewed by a lot of users. And then, if you keep doing the recompile, probably gonna slow it down, right? In terms
Right,
of data rendering.
right, right. So,
Okay.
so I just tell you, right, there's no one size fits all answer to this. I think the thing to do, right, is reporting services has that execution log table. If you deploy reports, you want to periodically go back and review those execution logs and just see which reports are taking a long time to run and how often they're being executed, right? Because
Hmm.
I don't want to spend time tuning something that's not used much. But if it's being used a lot or it's slow, then we need to get that back on the list uh, to decide how we fix it, right? Because it could be that we just need an index, right? It may not be a compilation issue at all. It could be that we just need to tune it, or we need to revisit how the query is written.
Hmm. Yeah. So would like data type such as integer versus small integer will impact performance much?
I'm going to go with it depends, right? So remember, one of our goals should be narrow columns, right? So what I would ask every developer is when you're creating a column, take a minute and think about what's the smallest data type I can use that reasonably carries us for the next few years, right? Say for example, there's a lot of times where we have a status, right?
Hmm.
0 equals inactive, 1 equals active, and we have 10 of them. Then I would go, don't use an int for that, right? Use a time unit, right? Go, that gives you plenty of growing room. You don't have to worry about it. A small int will take you up to 32,000. Uh, so there are plenty of times when that's, we need 1,000 values, and that gives us a lot of room. And on the other side, I would discourage anybody from using a big int unless they absolutely need, they know that they need a big int from the start because it is bigger, right? And it's remember, it's not just the bytes in the table, it's the bytes in the index, because we're probably going to index that value in a couple places. And we may store that value in other tables because it's relational, right? So just take a minute, 2 minutes, and go, what's the smallest data type that I can reasonably use, especially on the ints. Now on the varchar and varchar side, like something like last name, I would typically do like a varchar 50. What that says is it can't be greater than 50, but internally we're only going to use the space that it takes. So it doesn't hurt us to add a little extra wiggle room. But what I do keep an eye on is I want to add up the sizes of all the columns in the table and make sure if they were maxed out that we're not exceeding that 80, 60 bytes that we're trying to do, that is a page size essentially.
Mhm.
Excuse me.
Yeah. So another question, maybe a bit out of the time, but do you think MS Access is helpful for getting familiar with SQL Server? I'm not quite sure
Sure.
about the
No,
question.
no, 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 really, that's fine. It's Access is a really interesting product. I grew up on Access, as it were. It was really um, like the second relational database that I worked with. Um, Most of the concepts work the same. Um, if I had a choice, I would just get you to start with SQL Server, even though I think maybe the learning curve is just a little bit steeper. But it's where you're going to wind up. Access ends up being, because it's a consumer product, you just hit all kinds of limits with it if you try to build an application on top of it. And remember, you can get SQL Server Developer Edition for free. There's no reason for any developer, any student not to download that and work with that. But I think the advantage of Access is you can do something with the data in a way that you can't in Management Studio, and that is, create forms and reports and kind of build your own application in a lightweight fashion, which I think is really important because, we talk about relationships, but it's only when you go, okay, I've got this users table and I need to join it to the states table and to the countries table and everything else and turn that into an editable form that you really start to understand how joins add complexity and power, and Access lets you do that, right? Lets you do the form building and lets you kind of see in that low code type approach how to do that. Um, at the end of the day, what I would hope is that if you're working with a relational database, that I can get you to model well, right, to build the tables well, and to write the queries without using a query builder, right? The sooner you could let go of that crutch and go, I've simply got to learn the syntax of a select statement and inner joins and outer joins, that's when you start to become, useful as a developer, competent as a developer.
Thank you, Andy. I know it's 3 minutes past 10:30. Well, 10:30 Florida time. We have like three, four more questions.
Yeah, no, that's fine. Let's do them. What do you got?
Okay. Okay, cool. One of them is are stored procedures better for the plain cache than dynamic SQL?
That's a complicated question. I would say, in general, yes, but in truth, it's all about how the dynamic SQL is written. If you write SQL inline and you parameterize it correctly, you should get equivalent performance of the query and equivalent caching, right? As a DBA, I would tell you that using store procedures um, gives me better security, gives me more options to help you if something needs to be changed like now, right? And every once in a while that happens, right? So I try not to be a zealot about it, but at the end, store procedures are packaging, right? They're not about necessarily changing performance. They're really about packaging and saying, I want this to live on the database server, and then if the DBA needs to add a hint or I want to really restrict permissions, or I want to change how it works without recompiling the app, I can do all that in a very lightweight fashion and get great performance. But you can absolutely do it in line, but just most of it doesn't happen because developers don't have a deep enough understanding of what they're sending across and how SQL sees it to get the equivalent.
Mhm. Uh, so can you use SQL Server Profiler to see and monitor queries other developers are running?
Absolutely. So if you have alter trace permissions on an instance of SQL Server, then you can see 100% of what happens on that instance,
Okay.
right? And so that's why I want you to have SQL Server locally because I don't care what you do, right? You're just looking at your stuff, and it's why I'll probably never give you, profiler access to a production machine, or anything else where there's shared data, anything like that, because you can you can see everything.
Mhm. So which one performs better, CTE or temp table or table variable?
I would say in general, tip tables are going to be your best bet, but I like CTEs, and a lot of times CTEs are totally appropriate. My rule of thumb is if you're going to reference the CTE more than once in a single query, you're, you're probably better off to use a temp table, but it really depends on what the CTE is doing, right? If it's 3 rows or something, it may not matter. I like CTEs. I think they make queries more readable, right? And
Yeah.
they also are all in memory, right? It's there. But there are times when, because of complexity or reuse, you go, I want to move this out, and then you're picking between a table variable and a temp table. If it's a handful of rows, use the table variable. That's fine. Uh, but if it's going to be a lot of rows or a really variable number of rows, you're going to end up getting better results using a temp table.
So, okay, he also wondering if a stored procedure with a variable that is a big int, for better performance, using is, would you recommend to use a recompile or not?
If the store procedure is using a big int,
When a variable is using a big int
big int,
in a stored procedure.
no. So really, I would only use recompile if the I can't find. Let me see if I can say this a different way. Uh, Basically, when we have a query or a stored proc, we can only store one plan for that query. So if we can find one plan that works reasonably well for everybody, we're in great shape, right? That's why. So I take, go back to the example of a customer ID where there's exactly one of every number. It's easy to picture. Yeah, it doesn't matter if I'm looking for customer ID 1 or 700 or 700,000. It's all going to be one row. It's going to be great, right? Uh, the problem with SQL Server, with any database, becomes when you go, sometimes I'm going to get one row, sometimes I'm going to get 100, sometimes I'll get 10,000. Those are times when we might use with recompile because the distribution of the data is so varied that the statistics that we keep don't represent it well enough for us to figure out what to do with it in a one-size-fits-all plan, right? So it's not about the data type. It's really about the data that you're querying. There's nothing intrinsically about a big int or a GUID or anything else that automatically means you have to recompile. It's really about I can't find or I don't have time to find the one-size-fits-all plan, and so I'm just going to compile a plan each time based on the parameters. So I would just caution you, don't use that as your go-to at all. That should be I'm trying to get out of a jam and I need to get back to this like in the next hour to figure out something better, but maybe this gets me by right now to resolve a problem. That's really how I look at recompile.
Okay. Great. I think that's all the questions we have. Thank you so much, Andy. This is really an eye-opening webinar for us, especially for our developers who are not familiar with the DBA side of the work. And I really appreciate what you've done for this, to build SQL Central, SQL Server Central, and SQL Saturday and stuff. I, personally, I really benefit a lot from them, and I'm sure other people feel the same.
Well, I'm glad to hear that, and you're very welcome. I hope that you'll all pay it forward and help some other people learn.
Yeah, thank you so much, and thanks everybody for attending. Hopefully, we'll see you at our next session. Thank you.
Good night, everyone.
Good night.
Good night.
Thanks.